Hey guys, this is Ankit and welcome to the Terraform GCP task series. We are doing a list of basic tasks to get ourselves familiar with using Terraform for GCP. We are following the DevOps Engineer and SRE learning path, also available at cloudskillsboost.google/paths. To get more details, you can always refer to my repository, thecloudterminal01/learn-devops. For today's task, we have the following objectives. First, we will go through and understand the code base. After that, we will deploy a Kubernetes cluster along with the service using Terraform. The approximate time we will be spending will be around 9 to 12 minutes. So let's begin. Let's go over the code once before we start deploying. First, let's check the versions.tf file. The required Terraform version should be greater than or equal to 0.12. Now let's check the main.tf file. Now these are the variables defined for region, zone, and network name. These will be used to create the Kubernetes cluster. Over here we are creating a new network with the specified name. The name is tf-gk-k8s. Auto create subnetworks is set to false, which means that we will create subnets explicitly. Here we are creating a subnet with the specified IP CIDR range and associating it with the network created in the previous step. The name is var.networkName. This is the CIDR range. The network where it should belong is Google Compute Network.default, which is this one, .self-link. Now private IP Google access is set to true, which means that VMs in this subnet can reach Google API endpoints by using their IP addresses. Now this particular section retrieves the access token for the current Google user, which is used for authentication when creating Kubernetes cluster. This one retrieves the list of available Kubernetes versions for the specified location. Over here we are creating a new Kubernetes cluster with the specified name, location, and initial node count. So name is var.networkName, location is this. We want 3 nodes. The min master version is set to the latest available version of Kubernetes, which we are getting from this. The network and subnetwork are set to the name of subnet created earlier. Over here we are outputting the network, the subnetwork name, cluster region, and cluster location. Let's go to k8s.tf now. Over here we are using a provider for Kubernetes. The version of provider is 1.10.0. Now you might ask, why do I need to create a provider for Kubernetes? So in Terraform, a provider is a plugin that is responsible for managing and interacting with a specific service or technology such as Kubernetes. The provider allows Terraform to manage Kubernetes resources by using the Kubernetes API server. By creating a Kubernetes provider, Terraform can authenticate with the Kubernetes API server and perform operations on the Kubernetes resources such as creating, updating, or deleting Kubernetes objects. The provider block in Terraform configuration file contains the necessary authentication and connection information for Terraform to communicate with the Kubernetes API server. Without a provider, Terraform cannot manage the Kubernetes resources as it does not have a way to authenticate with the Kubernetes API server or understand the specific syntax required to interact with Kubernetes objects. So over here, we are setting the Kubernetes API server endpoint to the endpoint of the default container cluster. This sets up the authentication token to be the access token of the current Google Cloud Platform client configuration. This decodes the client certificate, client key, and cluster CA certificates using base 64 decode function. This is where we are creating a Kubernetes namespace for the staging environment. We are creating a namespace with the name staging. Here we are creating a Google Compute Engine address to use as a load balancer IP address for Kubernetes service. Over here, we are creating a Kubernetes service to expose the Nginx pods in the staging namespace. This is the selector for the service, run Nginx, session affinity set to client IP. This is the port configuration for the service. It will be running on protocol TCP. The port is 80 and target port will also be 80. The type of service which we are going to create is a load balancer. We need to attach an IP address to this load balancer as well. So we are attaching Google Compute address which we received over here to this load balancer. Next, we are creating a Kubernetes replication controller. Now you might ask, why do we need a replication controller? So in Kubernetes, a replication controller is used to manage and ensure availability of specified number of replicas of a pod. Replication controller helps to maintain the desired state of the cluster by ensuring that specified number of replicas is always running. So if a replica goes down, a new one is created to replace it. In the example provided, the replication controller is being used to manage the creation and availability of Nginx pods in the staging namespace. This helps to ensure that a specified number of replicas of the Nginx pod are always available. If any pod goes down, the replication controller will automatically create a new replica to replace it, thus ensuring high availability and fault tolerance for the Nginx application. Over here, we are defining the labels to match with the selector in Kubernetes service. This defines the pod template with the container specification. Over here, we are defining the resource limits and requests for the Nginx container. And finally, here we are outputting the load balancer IP address. So let's go ahead and start executing our task. First, I will be cloning the code using this command. So this is completed. Now let me go to this directory. We have already done this part. We have already gone through the code. So we'll skip understanding the code. Now let's go ahead and directly run Terraform init. Now let's go and run Terraform apply. I'll say yes. Let's wait for this to get completed. Our Terraform apply command is completed. So now let's go to Kubernetes engine and go to clusters. Over here we can see that we have a cluster with the name tf-gk-kts and it has 3 nodes. Let's go to services and ingresses. We have a service with the name Nginx already, and this is the external endpoint. Let's copy this endpoint and visit this page. This is the welcome to Nginx page. So this completes all of our subtasks. That's all for today. See you in the next video.